This lesson will cover factoring. The learning goal is to recognize when to use particular factoring methods with more complex trinomials, and the success criteria is you can apply your knowledge to common factoring, difference of squares, and trinomials to factor more complex expressions. So with factoring, remember it's an important technique used in simplifying and solving functions, and we have to look at the following methods of factoring. First is the trinomial, and in a trinomial, this is the kind of problem where you're looking for two numbers that would multiply to a times c, and also add to b. And a, c, and b is coming from the standard form of ax squared plus bx plus c. So in a particular problem, a and c are 2 and negative 15, so 2 times negative 15 is negative 30, and then b is negative 7. So we need two numbers that multiply to negative 30 and also add to negative 7. Those two numbers would be negative 10 and 3. Now those two numbers allows us to take the negative 7 and split it into the two values to add to it, so negative 10 and 3. And this would then give us the following line. We'd have 2x squared. Now it doesn't matter the order of which value you put first. You can put negative 10x, or you can do plus 3x. Doesn't matter which one. In this case, I'll put minus 10x first, and then plus 3x, minus 15. And I like kind of like this form more because that allows me to factor from the x's here and the 3x minus 15 on the other side. They're common factors, but again, it does not matter. So here I'm going to factor both halves of my expression here. From 2x squared minus 10x, I can do a common factor from these two terms of 2x. Remember, with factoring, it means you're dividing each term by what you're factoring out. So 2x squared divided by 2x, that is x, and minus 10x divided by 2x, that is minus 5. And then on the right, we're going to factor out a 3. We can factor out 3 from 3x and 15. So that's plus 3. That gives us x minus 5. The whole goal of this is we want these two brackets to be the same, which then allows us to use the laws of distribution to rearrange this to be x minus 5 times 2x plus 3. So that is factoring a trinomial using the method of splitting up your b value into two different values. Those two numbers also multiply to a and c. Now for a difference of squares, a difference of squares means that you have a subtraction of two terms which are square values. So when you're working with these kinds of problems, you are looking for the squares, the square roots of your term. So in this case, I have 9 and 16a squared. Now remember, with exponents, if I have, for instance, x squared is equal value to x times x. So in case of a squared, we can do a times a. So difference of squares, we're just going to create two brackets here. One is addition, one is subtraction. On the left here, we need the root of 16a squared. So the root of 16 is 4, so that's 4, and the root of a squared is a, so that's 4a. And then we need the root of 9, that's 3, so 4a plus 3. And then on the other brackets, the exact same values, 4a, in this case, minus 3. So that's the difference of squares. You're just looking for the roots of your two terms in two brackets where one is adding and one is subtracting. Now for common factors, it can either be numerical or it can be a variable factor. So for example here, we have 12x squared minus 2x minus 2. This looks like a complex trinomial where we have a value, but we can also make this a bit easier by common factoring out. So a common factor between all these terms is 2. I can divide 2 out of all of 12, 2, and 2. So that gives me 2 times 6x squared minus x minus 1. And now this works in the same way as a trinomial as we did above, where we need two values that multiply to a and c and also add to b. So our b value here is -1, our ac value is -6. So two numbers that multiply to -6 probably be you would either do 1 and 6, but 1 and 6 won't really add to 1. So it's more likely to be 2 and 3, with 1 being negative. In this case, it's going to be -3 and +2, because -3 plus 2 is -1. So this now gives us 2, 6x squared, and we can do minus 3x plus 2x minus 1. And again, we're going to factor out of the left side and right side of this expression here. So that gives us 2 again on the outside. Here we can factor out a 3x, so 3x. And that gives us 2x minus 1. And on the left right here, we can't really factor anything out. If you can't factor anything out, that means you're going to factor a 1 out. So that's plus 1. And it gives us 2x minus 1. Finally, that gives us 2 times 3x plus 1 times 2x minus 1. The whole time we have this 2 that we factored at the beginning, it's going to lie outside the brackets. And finally, we can have a common factor, but it's also a variable. This one's a little more, can be a bit more difficult because it does look quite large, can be quite ugly at times, but it is totally doable. So in this particular case, we have 18x squared times y plus 1 minus 50x squared times y plus 1. First things first is we can notice of these two terms, we have two terms here. Both of them share a y plus 1. So we can factor out y plus 1 from both these terms. Now we can also look at a 50x to the power 4 and 18x to the power 2. We can also look for a common factor between these two terms. Both of them are even, so we can definitely factor 2 out. And both of x's, we can factor x squared out. So we can factor out 2x squared, y plus 1, from both terms. So let's use a square bracket here. 18x squared, when we factor out 2x squared, that's going to give us 9. And then minus, we factor out 2x squared from 50x squared. So 50 divided by 2 is 25. And then x to the power 4 divided by x squared, that's x squared itself. And the y plus 1s are both factored out here. So I can't really do anything outside the bracket here, but I can factor the 9 minus 25x squared. That is a difference of squares. So our coefficient here, the 2x squared, y plus 1, that still remains. And then we have two brackets, plus and minus. The root of 9 is 3. The root of 25x squared, that's 5x. So it's 3 plus 5x and 3 minus 5x. So these skills are very important to factoring as you move forward. Trinomials, difference of squares, and then common factoring. Common factoring either with just numbers or with full expressions or variables. Some algebra expressions that may look more complex will factor in similar to ways above. When factoring, look for patterns and expressions you can use to identify what factoring technique to use. So for example, I'm going to simplify each of the following here. First, we have x power of 8 minus 3x power of 4, y minus 10y squared. Now in this problem, this has three terms, so we can look at this as a trinomial, and we want to kind of use that technique. But we'll notice that we have two variables here with x and y. Now what you'll notice is we have x power of 8, x power of 4, and then kind of like a constant, that's minus 10 here, if we look at just the x's. If we look at the y's, it's y squared, y, and a constant. I think it was a 1 over here. So we have two trinomials in reverse here. Now, when you factor these, you have a choice. You can either factor as normal through a trinomial, or you can also remove one of the variables and put it back on at the end. In this case, I'll show you how to do it just using a regular trinomial technique. So we follow the same technique here. We find two numbers that multiply to a and c, and two numbers that add to b. So a and c here is 1 times -10, so that's -10, and b is -3. So that would give us -5 and +2. So we are looking, oops, there we go. We're looking for two values here, -5 and 2. We're going to split that -3 up. So it's x power of 8 minus 5x power of 4y. You keep the same variables, plus 2x power of 4y minus 10y squared. Again, we're going to split in half and common factor out both sides. The common factor on the left here is x power of 4. X power of 8 divided by x power of 4 is x power of itself. And minus 5x power of 4 minus y. When you factor that, it's just going to be minus 5y. And then we have plus. Here we can factor out, they're both even, 2 and 10, so we can factor out 2, and they both share y, so we can factor out 2y. And taking 2y out of this is going to give us x power of 4. And -10y squared divided by 2y, that is minus 5y. Again, gives us the same two brackets that we're looking for. So here, our factor form is x to the power of 4 plus 2y times x to the power of 4, whoops, that's an extra bracket, times x to the power of 4 minus 5y. So factoring these kinds of problems, it follows the same steps as a trinomial. It may look quite ugly at the beginning of all those variables, but look for the pattern, look for the kind of structure of a trinomial, binomial, or anything else in between. In some cases, you can also expand first and then simplify. Okay, let's have a look at B here. Well, looking at B, B has the form of a difference of squares. We have two values here. We have 81a to the power of 12 minus 16, and we can check that. Yeah, 16 is it is a square number at 9. I mean, 81 is also a square number. And a to the power of 12, it's even exponent, so it is a square. It's a to the power of 6 times a to the power of 6. So we can factor this as a difference of squares. So two brackets. 81, the root of 81 is 9. Root of a to the power of 12 is a to the power of 6. Then it's minus 4. And then we have 9a. Actually, let's do plus for first. 9 times a to the power of 6 minus 4. So we'll change it around because when I actually look at this factor form we've created, it turns out that this bracket on the right can also be factored. It is a difference of squares. So we have 9a to the power of 6 plus 4 staying here. And then we can factor this bracket. 9 is a square number, 4 is a square number, a to the power of 6 is an even exponent, so it is a square. Root of 9 is 3, root of a to the power of 6 is a to the power of 3, and that's minus 2, and then 3a to the power of 3 plus 2. We can't go any further here with actual whole numbers, so this is our fully factored form of this difference of squares. So be very much aware of this when factoring, is you can encounter problems where you have to factor multiple times.